All right, after helping several students with this and figuring out the best way to do it, I realized some of what I shared earlier is not the best. So getting started with the gears, I'm going to start off creating a sketch, and on that sketch, I'm going to actually center. And again, I'm set up in millimeters. I just drew my first line, and I'm going to actually center this thing by using a midpoint constraint. So my line right now is centered on the origin, and what I'm going to do is I'm going to make that a construction line by hitting the letter Q. From there, I'm going to create a slot. It's under this drop-down option, and the slot I want to be solid, referencing that line. So I just hit the letter Q to make the lines outside solid, and I can make this 30 millimeters in radius, which I like. And when I click out of it, just click on outside my object, you can see I now have a backer board on which I can do stuff with. I'm going to hit the letter D, and I'm going to actually assign the distance from pin to pin. And this is pretty small right now, but I'm going to title mine at 150 and make it a little bit larger. And what this ensures is across this dotted line, I can put locations for which to have pins. The pins are what will anchor my gears. And I need a place for my gears to spin around, so that's kind of why we're starting with this. We can also change this number later, and it will scale up and down. The one thing I want to do first is using my circle tool is to put some locations on which I can start putting some pins. So I'm going to hit number 1 for a 1 millimeter hole. This is very small. I'm going to come over a good distance, put another one, come over a little bit, put another one. And I just want to put a few of these throughout my model, making sure that none of my circles at this point are on my midpoint. I don't want to anchor to the midpoint of this line. If you do, it's going to constrain things in unwanted ways. Next I'm going to do is I'm just going to assign dimensions from circle to circle. These are just arbitrary dimensions at this point, which will later need to be changed, actually made very precise based on the size of the gears that are trying to interact with each other. All right, so again, I got all these locked down, didn't type any specific dimensions in. We can adjust those later. All right, I'm going to close this. The next step, I'm going to extrude this and make this into a backer board. In this case, I'm going to create a new object. I'm going to select my model, but I don't want any of these holes. So I'm going to come back into my holes and close them. Yeah, I should have probably just zoomed out and dragged a box over all of it and selected all of it. And I want to make this 25 is a little extreme. I'm going to make it 2.5 millimeters thick and be done with it. All right, so at this point, I have a 2.5 millimeter backer board on top of which I'm going to associate my pinholes. I'm going to go back over to my sketch and turn on my sketch so I can see my holes. Next thing I do is I want to pull some pins out. So I'm going to extrude, make an additional extrusion. This extrusion I'm going to call 5 millimeters deep. You'll see why in just a moment. I'm going to add some pins to this board. Probably going to need to change the direction if I had to guess correctly. And I'm going to select I see what happened. So my original sketch was going the opposite direction, my original extrusion. So let me get out of here. I'm going to start that over. Let me go back to my other extrusion. I'm just going to change the direction of this. So what I did is I pushed my extrusion back away from me, so I now have access to these holes. Let me go back to my front view. I just selected all of the holes so I can make an extrusion more quickly. And I want to add these. I want to make sure they stick out the front. 5 mils probably plenty. And I'll hit the checkbox. All right, so now I have backer boards. The hole spacing can quickly be changed later. If I go back in here and say I want this to be 30 mils apart, I can type in 30, and now my pins will be 30 millimeters apart. All right, with that, I want to show how to not only just construct your gears using the spur gear, which you should have added by searching for the spur gear, add it to your tool palette. If you don't see it, you see this dotted box. It means it hasn't been used recently. Since I used mine recently, I'll select my spur gear, and I'm going to create its size. So the depth of a spur gear, in this case, I'm going to leave them at 2.5. I made my pins 5 because we're eventually going to have to stack and make our gears a little more complex. I'm going to make this gear 60, all right, for my demonstration purposes. 60 teeth. I want my module to remain at 1, and what you'll notice is that the diameter of my gear is now 60 millimeters across, all right, which is really nice if you keep that in the back of your mind when it comes to the math later by leaving this a 1 millimeter module. I'm going to add a center bore to match the size of my pin, which is 1 mil, and be done with my gear. All right, now what we notice is my gear is just floating in the middle of my object. It's not on any of these pins. So I'm going to come back into my spur gear, and I'm going to select a mate connector. Mate connectors are physical geometries that you can now associate the center of my gear to. So I'm going to go to the base, the center of the base of that pin, and it should have, I'm not sure what I just clicked there, why that got messed up. There we go. Click the center of that base. Not sure what I clicked on the first time around. And what it did is it now put my gear on top of that pin with the back edge of my gear against the plate that we're referencing. All right, so I now made a 60 mil diameter gear. It's a 60 tooth gear. And I noticed that I'm like already up against this pin. That's not going to work real well. So I'm going to make an adjustment here. The diameter from the center of my gear to the edge is 30 millimeters, and that's what I just wrote. So my mesh point is 30 millimeters away. So I now want to change that. I'm going to actually make a second gear, but I'm going to make it at 30 teeth. And so half of 30 is 15, half of 60 is 30. So I want to make them actually 45 apart. So going back into my sketch, I'm going to type in 45. It'll push my other points away. And I now want to create a second gear. As I just mentioned, 2.5 is good. 1 mil, except I want this to be a 30 tooth. Still want a center bore of 1 because it's going to go on a pin eventually. All right, and now I got to locate this where I want it. So I'll go back into my gear, select the mate. And the mate that I want to use is this next pin over that I just placed. All right. As a result, I now have 2 gears that are perfectly meshed. Their pitch diameters touch, just kiss at one spot. They're not overlapping. They're not avoiding each other, which means these 2 gears' teeth will mesh perfectly later. All right. For the last step, what I'd like to demonstrate is to stack some gears on top of each other. If you take a look at the relationship between these 2 gears, I got 60 teeth to 30 teeth. Every time that this larger gear does 1 revolution, this smaller gear is going to do 2 revolutions. So I'm getting double the revolutions on one gear as I am the other as a byproduct of being half as many teeth. Again, mathematically, you got to take some time to picture it. Hopefully, once you start animating these together, you'll get a better picture for it as well. So what I'm going to do is I'm going to step this up back to a 60 tooth gear, which we could later interact with again and create mechanical advantage. Basically speed things up or slows things down by stacking gears on top of each other. So the next gear I'm going to do is I'm going to stack right on top of this, and I'm going to go back to another 60 tooth gear, which is why I left a 5 mil pin at only 2.5 mil thick gear. So let's add one more gear. Let's make this gear 2.5 as we did the rest. Let's make this a 60 like the original. It's a 1 mil module, so it matches and meshes with all the others that we previously created. And we got a center bore of 1. From here, I can assign the pitch diameter. I mean, not the pitch diameter, the mate connector. And I want this to be the center of the pin, but on the top of that blue gear. All right, so that's good. So now I have 3 different gears. Gear 1 is turning into gear 2, or will, and then I need gear 2 and gear 3 to be connected, to mesh together. And so what we can do is down here now that I have a 30 and a 60. And then when I highlight them, I can see the two gears. I can take both of them, and a quick right click allows me to Boolean, which allows me to union, mesh them together, remove one from the other, or just intersect them. So right in this case, I want to union them. All right. What you should notice is that both of these gears are now the same blue. They act together. So when the back 30 mil gear turns at half the speed, so will my front gear as well. All right. At this point, let's put an animation together, and we can see how we can create mechanical advantage. And again, by creating gears of different sizes, we can create different speeds as they revolve. So to do this, we're going to go over to an assembly. I must have had an assembly already started. I'm going to delete that fresh. So coming up to the top left corner, I got an insert option. I can go to my entire part studio, which is what I want to do in this case. And I just want to drop it in here. So at this point, all of these three pieces are freely floating. All right. We don't want that to happen. So I'm going to put my base in a position and right click and fix it. Fixed means it cannot be moved anymore. I get this little icon when I try to move it saying that this is a fixed piece. Don't mess around with it. Next part is to apply a revolute mate, telling these pieces how we want them to interact. So I want the back side, well, the front side of the base plate to interact with the back side of my gear, as I did in my part studio. And I'm going to hit the checkbox. So I just drop that where it belongs. Need another revolute mate on the next pin over and on the back of my 30-tooth gear. And they all move together because they are Booleaned, meshed together. All right, so I now have two gears. May look like they're the exact same gear, except for we have a half-size gear on the back side. And so we'll check out the relationship between these in just one moment. So next thing we need to do is to create a relationship between our gears. And this is the gears that are touching one another. So at this point, I need to select mates. So the revolute mate is the first one. This is the gear on the left. The second is the gear on the right. And I need to speak to the relationship between these two gears. So I have a 1/2 relationship. And if I hit the checkbox, what you'll notice is that for every revolution that I do on the left gear, I got a half-speed revolution on the right gear. If you can't see what's going on, which you can't because that gear is on the back side, and hopefully this looks right, hopefully I did this relationship properly, I can go and make that backer board transparent. And I can try to, let me see that. All right, I have my relationship backwards, which is why it doesn't look good. Let me double check the gear relationship. And 2/1. A little bit of trial and error. I think I had to deal with the direction I was selecting things. All right, now I can see that the two gears are meshing. I'm going to turn this off, turn my transparency off, come back to the front. I think it'll look a little better in just one moment. There we go. So for every revolution the gear on the left makes, the gear on the right makes 2, which is why you'll see the speed looks kind of doubled up. All right, so we just doubled up on the speed between those two gears. Even though these two visual gears are different sizes, that smaller gear in the back is what's changing the speed by 1/2 or is being doubled depending on the order you're driving it. So again, for every revolution the one on the right makes, the one on the left